G'day, Professor Glenmo here again. Now, today I want to talk about the difference between a self-managed battery and a managed battery. Now, what I got behind me are some lithium ferrophosphate batteries. These are from Power Plus Energy. In fact, these are the engineering samples, so they're not the ones that you would find when you purchase them. They've got some extra boards for monitoring, so kind of an R&D project. But these are basically the engineering samples for the Life 4838P series. These are 48 volt nominal, well, more technically 51.2 volts nominal, and they've got a rack mounting capability. So what's special about these is that they're a self-managed battery. That means they don't need any communication with their charging source, whether that be a maximum power point tracking charge controller or an inverter. Basically, you would just set the charging source to suit the voltage parameters, the charging current, the minimum voltage settings for these batteries in the charging source itself, and the rest will look after itself perfectly well. So the batteries look after themselves. As if you exceed some of those ranges, they will self-protect. And that's the other thing about these self-managed batteries, is the protection that's built in is pretty substantial. They've got internal FET switches in addition to a circuit breaker. So on the front here, we've got some circuit breakers, and these circuit breakers are sort of like the ultimate shutdown point in case if anything else fails. The circuit breaker can still trip in an overcurrent situation, but it's also the on-off switch for the battery modules. So how do they protect themselves? Well, they're constantly monitoring the voltage of the strings within the cell pack, and if they exceed the safe operating range, they'll open their charging FET and basically stop them being overcharged. Equally, if you over-discharge them, because lithium-ion batteries don't like to be over-discharged, at the cutoff voltage, the discharge FET will disconnect, and they'll stop discharging at that point. Now, these are parameters that are there for protection. You don't want to rely on them. You want to make sure that you charge and discharge within the safe range, but it's there just in case stuff goes wrong. They've also got thermistors for monitoring cell pack temperature, and so if they're too cold or too hot, they can manage their safety as well. So, self-managed batteries will work with any charging source that you can program the voltage and current settings appropriately. That means they're very flexible. What's the drawback? Well, the drawback is that you're not getting a lot of data. These don't communicate with a charging source, so you don't know much about the batteries other than its voltage and current. So you're not getting the detailed information about the cell packs themselves. But whether you need that or not is questionable. The other limitation is that they have to work in a slightly safer range than what we'll look at next, a managed battery. Because they don't want to push the limits of the battery pack's capabilities, they'll always design them with a safety margin built in so that the internal protection systems have an opportunity to kick in as a last resort. Right, let's go and check out a managed battery. Well, here we are in another lab, and this is fondly known as the boat shed because it used to be a boat shed, but there you go. So in this lab, we've got the Weco batteries. Now, this is a new product in the lab for me, and I've been learning quite a bit about them. Weco batteries can be a managed battery. That means that they can be controlled by their charging source. So in this case, we're using up here a Goodwe high voltage hybrid inverter. This is the GW5000EH. It's a 5 kilowatt hybrid inverter, and it takes a high voltage battery stack. And what we've got here is actually 4 of the Weco batteries. These are 5.3 kilowatt hours each, and they're nominally a 51.2 volt battery, but they can be connected in series. Because we've got 4 of them, that'll give us a 200 and something volt string, which is ideal for the high voltage Goodwe inverter above me. So, what's so special about a managed battery? Well, for a start, the communication with the charging source gives a lot of information about the state of health, the state of charge, and other parameters of the battery. With that information, the charging source can actually drive these batteries much harder safely. It's kind of like a automatic braking system that you might have on a car. It's an automatic charge control system built into the BMS. Now the BMS is actually a separate unit right down the end here. That's the BMS, and these are the battery modules. So the BMS itself will do that protection. So it's got internal contactors, DC contactors, to disconnect if there's excessive discharge, charge, voltage, over voltage or under voltage, and temperature. So all of that is managed as well. So I guess in summary, a managed battery can be driven harder and faster safely, and you can get more capacity out of it, but you will have to use a compatible inverter. So possibly the drawback is that you have to kind of check what inverters is your managed battery compatible with. In the case of the Wecos, it's a huge range. So we had no trouble finding many inverters here at the lab that these Weco batteries will work with. So that's the difference between a self-managed and a managed battery. This is Professor Glenmo, out.